Good morning friends, I welcome you all in this session. As you are aware that in previous session we were discussing about Hillier model of measuring risk of a project, and we have seen couple of things. We did calculate expected cash flows from different projects in different years, right, and we were given net cash flows and their probabilities. So, this was the problem we were looking at. Keep in mind that there are two types of situations in Hillier model. You got unrelated cash flows and related cash flows. When I say unrelated cash flow means the cash flow of second year does not depend on cash flow of first year. In other words, there is no correlation between cash flows, right. And in case of correlated cash flows, you will have relationship between cash flows of different years, right. So, let us look at this example which we have solved in previous class also, but we did not solve it completely. So, a project with initial investment of 100 lakhs with a lifespan of 4 years has the following probabilistic outcomes in different years, right. So, net cash flow in first year is 30 lakh and its probability is 50%, right. Net cash flow 10 lakh, probability is 30%, right. Keep in mind that this probability is 100%, right. Some of these probabilities should be 100%. Similarly, for fourth year, net cash flow would be 60 lakh and its probability is 30%, 20 lakh its probability is 15%, right. So, what we want to find out? We want to find out expected net present value of the project and its standard deviation, right. So, first we should calculate these two terms and then determine the probability of positive NP of 30 lakh, right, and what is the probability of that the project would suffer a loss, right. Assume 10% as discounting factor, right. So, this is what we calculated in previous session. Projected cash flow for first year was 28 lakh, for second year it was 37.5, for third year 47, for fourth year it was 43. And how did we calculate these values? We just multiplied net cash flows with respective probabilities and we did add all these multiplications, right. So, this is how we obtained expected cash flows, right. Now, to find out NPV, NPV of this project would be this. In fact, I have written a formula over here. So, NPV is the expected NPV is summation of all the years t ranging from 1 to n, in this case 1 to 4, expected cash flows divided by 1 plus I to the power t, right, minus investment. So, you need to calculate this NPV. For this you need to calculate, first of all, let us calculate this, right, though we have already calculated NPV for this particular example and our answer was 21.13 lakh, right, isn't it. So, let us look at standard deviation. This is summation of t ranging from 1 to 4, this variance divided by 1 plus I to the power 2t. Keep in mind this is 2t, right. So, for first year it would be 2, second year it would be 4, third year it would be 6 and for fourth year it would be 8, right. So, you have to take under root of this whole term, right. So, how to find out this? Let us calculate for first year, right. So, this is probability is 0.2, then cash flow is 50 lakh minus expected cash flow, right. So, this was 28 lakh, right, this was 28 lakh, right, whole square, isn't it. Then 0.5, just see this here, it was 0.5 into 30 minus 28, right, whole square, right. So, the third one would be 0.3 into 10 minus 28, right. So, what we have done in this, when we are calculating variance for first year, what we are doing, we are subtracting expected cash flow from net cash flows, right, and we are multiplying by their probabilities also. So, for this first year it is 196, right. So, this would be 196, right. Then for second year, how would you do it? For second year, you should start like this. First is probability 0.25, right. 60 minus what is the expected cash flow of second year is 37.5, right. Then it's square, right, plus what is the second probability, it's 0.5, right. What is net cash flow? 40 minus expected cash flow, which is, this will remain same, right, 37.5 square, plus the next probability would be 0.25. Cash flow is, for second year it is 10 minus 37.5 whole square. Just add all these things, you will get variance for second year, right. Similarly, for third year, how would you calculate? For third year, first probability is 0.4, then net cash flow is 70, expected cash flow is 47 lakh, right, whole square, plus probability 0.50, expected cash flow 40 minus 47 whole square, plus 0.10, right, because this probability sum should be 1, right. So, for third year it is minus 10 minus 47 whole square, you will get some answer, right. We will calculate these answers as well, right. For fourth year, this would be 60 minus, so first of all probability 0.3 into 60 minus what is expected cash flow for fourth year, it is 43 lakh, right, plus probability next is 0.55, right, cash flow 40 minus 43 whole square, plus point, the remaining one would be 15, right, and net cash flow 50, expected cash flow 43, right. So, you just calculate these values, and these values would be nothing but, for second year it would be 318, for third year it would be 561 and 171, right. So, 318, 561 and 171, right. Now, let us calculate this value, standard deviation of NPV, right. Keep in mind, you need to apply this formula now, right. So, what to do for this? For this, NPV is equal to, you need to look at the, this is what we have calculated for first year, right. For first year it was there in previous slide. So, for first year it was 196, right. This is for fourth year, this is for third year, this for second year, and for first year it was 196, right. So, how to proceed now? 196 plus 1 upon, and what is your discount factor here? The discount factor is 10%, right, is there in question itself, right. Just see this, this is discounting factor 10%, right. So 196 divided by 1.1, 2 into t, right, t is 1, so this square, plus 318 divided by 1.1 to the power, now t is equal to 2, so this becomes 4, then 561 1.1, this is 6, plus 171 1.1 to the power 8, right. Under root of this would be your standard deviation of NPV, and that value is 27.86, right. So this is how you can calculate expected NPV and standard deviation, right. Now the second part of this question is, what is the probability of NPV is 30 lakh, right. So we know mean and standard deviation, right. So mean is also available and standard deviation is also available, right. So this is your standard deviation, okay. Now what is the probability that the project there would be positive NPV of 30 lakh and more than that? For that you need to calculate Z value, right, and Z value is x minus mu divided by standard deviation, right. So mean is 21.13 for this particular problem. So how to draw a distribution for this? So the distribution would be like this. Mean is 21.13, right, and standard deviation is just what we have calculated here, it is 27.86, right, 27.86. Now calculate Z value, because what is the probability that it would earn 30%, 30 lakh rupees, right. So this is 21.13 and this is 30, right. So when I say, if I ask you a question, what is the probability that the project would earn or what is the probability that the project would earn this much NPV. Now this is always at 50%, right. So you can always say that it is the probability that project would earn 21.13 lakh is 50%, right. So beyond this side it would be more than 50%, this side it would be less than 50%, right. So our question is, what is the probability that the project would earn a positive NPV of 30 lakh and more, right. So what is the area under this curve, right. So for that you need to calculate Z is equal to x minus mu divided by standard deviation, right. So x is nothing but 30, right. So 30 minus 21.13 divided by 27.86, this is equal to 0.318. Now look at the Z value, the Z table, to know what is the area under curve when Z is equal to 0.318, right. So let us look at Z table and area where Z value is 0.318, yeah. So 0.31, 0.31 is 0.1217 and 0.32 is 0.1255, right. So it is somewhere between these, right. So for 0.318 area under would be somewhere between these two, right, and that area is 0.12, okay. Let us take that value as 0.12. So 0.12, right. So area under this, let me use a different colored pen. This is 0.12, right, and this is 50%, right. So what's the probability that it would earn more than 30 lakh? You just subtract this value from 50%, right, and that would be around 37.53%, right. So this is how you should calculate, because we know this area is 0.12 and this area is 0.5 minus this value. So you will get 37.53, right. Now what is the probability of loss for this particular project? Take x is equal to 0, right. Again calculate z value, which is now minus 0.75. Now you need to look at area under curve. So minus 0.75, look at z table, 0.7 and 5 is this, right. So 0.2734, it is whether positive or negative side, right. When it is negative side, you just take this side. If it is positive, that would be this side, right. So when I say 0, it means somewhere here, right, and area under curve would be 0.75. So this is 0.2734, right, 0.2734. This is area under curve, 0.2734. Now since you want to know this value, because this area is 0.2734, right, just keep in mind this area is 0.2734, you want to know this area. So 0.5 minus 0.2734, you will get 22.42 as your answer, right. So probability of making a loss as far as this project is concerned is 22.42%, right. So this is how you can solve a question if you want to calculate mean, the expected NPV and its standard deviation, right. So far we have seen a case of perfectly uncorrelated cash flow, right. Let us look at another example wherein cash flows are correlated, right. When I say correlated means the cash flows are almost similar in different years, right. So this is the question and you need to solve this question. Now this is a question wherein you have already been given expected cash flow, you need not calculate, right. You have not been given probabilities. So rather than calculating expected cash flow from net cash flow and probabilities, you have directly been given in this question expected cash flow plus standard deviation is also available, right. So the question is like this: determine the expected NPV and probability of earning at least 50 lakh and probability of making at least no loss with the following information, right. And initial investment is 150, discounting factor 12%, right. So you need to apply the formula which I just wrote on board. You can again see that formula. So this is expected NPV is equal to summation of t ranging from 1 to n expected cash flow 1 plus I to the power t minus initial investment, right. This is what we have calculated, right. And standard deviation of NPV is summation of t ranging from 1 to n one plus I to the power 2t, right. This is I, right, this is t, right. So, the difference between previous formula and this formula is that this is just t, it is not 2t. In earlier formula it was 2t, right. So, let us solve a question, or if you want, you just solve this question. So, for this question NPV is 40 by 1.2, 60 by 1.12 square, 80 by 1.12 cube, right, because t is, you need to just increase value of t by 1 every time, right. So, NPV for this project is 63.34 lakh, right, and standard deviation of NPV is 6 divided by 1.12, because you have been given standard deviation, right. So, this is 6, 8, 10, 9 and 7, and since you can also calculate 1.12 to the power 2 cube to the power 4 to the power 5. So, this becomes 28.4 lakh, right. Now, this case is of uncorrelated, right, uncorrelated cash flow, right. This example is not of correlated cash flow. So, we will do the example in a way which we did earlier example, right. So, this is 28.4 and the probability of earning at least 50 lakh is this x minus mu divided by standard deviation, right. So, standard deviation is this, mean is this. So, what is the probability that the project would be earning at least 50 lakh? Just calculate area under curve at z is equal to this, and finally the answer for this question is 68%, right. So, the probability that this project would earn at least 50 lakh rupees is 68%, right. Okay. And the probability that the project will not suffer a loss or is, you just put x is equal to 0 minus mu divided by standard deviation. So, z value is minus 2.23 and area under curve is 98.71, right. So, the corresponding probability of at least making no loss is 98.71%, right. Now, we will solve two more questions related to this Hillier model. Again we will take one case of uncorrelated cash flow and the other case would be of related cash flow, right. So, let me write those two questions and then we will work out those questions. Questions are very simple. So, first of all we will do it for uncorrelated cash flow, and for uncorrelated cash flow this formula becomes 2t, right. And question is like this. So, net cash flow in the first year with probabilities are given. So, this is 3000, 0.3, 5000, 0.4, 7000, 0.3, right. This for first year, right. For second year you have got net cash flow 2000, 4000 and 6000. Probabilities are 0.2, 0.6, next would be 0.2, right. Then for third year, net cash flow and probabilities, right. So, net cash flow 3000, 5000 and 7000. Probabilities are 0.3, 0.4, remaining would be 0.3, right. So, now and the discounting factor is 6% for this question, 6%, and initial investment is also given, it is rupees 10,000, right. This is your initial investment. Okay. Now, you need to work out this question. So, first of all calculate this value, right, NPV, expected NPV. How would you do it? Just try for this question. So, you need to calculate expected cash flows first, right, for all these years, right. So, how to proceed? Let us solve this question. So, expected cash flow is known to you. This is this and net cash flow into probability. So, this 900, this is 2000, 900, 2000 and 2100, right. So, this becomes how much? 900, 2000. So, 2900 plus 2100, this is 5000, right, divided by 1.06, right, to the power 1, right, isn't it? So, let it be like this. Second, expected cash flow 400, 2400. So, this becomes 2800 plus 1000, 1200. What is that value would be? Just calculate. 400, 2000, 400, then so this is 2800, 3600. I think this is right. Let me check whether this is right or not. Yeah, this is actually 4000. There is something wrong. So, this is 4000, this 4000, summation of this is 4000, this 2800, 3000 and 4000, yes, 4000 divided by 1 point square, right. The third one would be 900, 2000, right, then 2100, this is 5000 divided by 1 plus 0.06 minus initial investment is 10,000, right. So, this value would be, you just calculate, and that value is actually this is 2475, right. You can calculate this, you will get this answer, right. So, this is how you can calculate NPV, right. Now, standard deviation. How to calculate standard deviation? Using this formula, right. So, first of all you need to calculate this value, isn't it? So, how to find out this value? We did it in previous example, right. So, sigma 1, this is the variance of first year is how to proceed? There is a probability 0.3 into 3000 minus 5000. What is this 5000? Expected cash flow in first year, right? Plus 0.4 into 5000, this value, net cash flow, minus 5000 plus 7000, before that its probability, so 0.3, 7000 minus 5000 square and square of this, right? Okay, so this is what we were solving. Sigma 1 square is equal to this, and the answer to this is 240000, right? 00000, right? So this is what is the variance of first year, right? Similarly, you can calculate variance of second year and third year, right? Let me write those values for your convenience, and those values are this 16000000 and 24000000, right? So with this we will solve the remaining part of this question in next session, right? Because we did not find out so far this value, right? We just calculated these values. Okay, otherwise let me finish in this session itself. So you have got 24 divided by 1 plus 0.06 square plus this plus 16000000 divided by 1 plus 0.06, this is 4, right? 2 into 2, 4, right? Plus, so this plus 1 plus 0.066, right? And this, when you add all these things, your final value would be 2258, right? So this is your standard deviation of the project, and NPV you have already calculated, which is 2475, right? So this is a case of uncorrelated cash flows and Hillier model, right? So with this, let me finish this particular session. We will have next session, and in this next session we will talk about correlated cash flows. Thank you very much.